Oh, hey Miss T, if you're trying to draw the flag of British Columbia, I might recommend a few changes and fewer colors.
No, Mr. A. This is what they call a sunset on the horizon. Many students tend to confuse the words horizontal and vertical, so I figured, well, if you're thinking of a sunset, you're watching the sunset across the horizon. And the horizon is a horizontal line. And vertical talks about up and down, like this person's sick vert.
That really is a sick vert.
Man, they're jumping higher than their total height.
Yeah.
Could you imagine being 6 feet tall and having like a 6 foot vertical? That truly is a sick vert.
So today we're going to look at horizontal and vertical lines and their equations for those, the graphs of those. Here we have a horizontal line right over there. We know it's horizontal, it's just going left, right.
Looking at our graph of that horizontal line, notice we don't get it confused with the axis, which is so common in so many ways. But notice the axis is labeled with its letter, right? It might be X, oftentimes it is. It might be a different letter, but this horizontal line is not labeled as such. Notice that my axis also has a scale marker to tell me what it's going up by. So don't get those two confused.
No, that would be horrific. When we look at this line, now noting that it's horizontal, we've already established in previous topics that the rise of this thing is 0. And we could just calculate this by throwing in another point here. Going from point to point, it rises 0, it runs 5 in that span. So its slope is just a straight up 0. And if we were to put that into slope-intercept form, we'd end up with just this, where we take y equals mx plus b, but the m is actually 0. So it's just y equals b, where b is the y-intercept. That y-intercept is the same y value as any other point on this line. This has a height of 4, 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 and it's always the same y value. So a horizontal line will be the same height above or below the x-axis, no matter where on that line you are. So by that rationale, it's again just y equals whatever that y value is. So when you look at taking a line like this, which goes through the point 2, 4, and getting its equation, again we've already established that it goes through it has a y-intercept of 4, so it's y equals 4. But again, you can just say, since the y value is 4, that therefore all y values will be 4. So you can have this equation, just straight up y equals 4. If you want that in general form, which would be ax plus by plus c equals 0, we wouldn't have any x component of that. So you'd just be looking at this, and which is why you have a leading positive y coefficient there.
All right, so we're going to take a look at the next 4 examples. They're all going to be pretty quick because given one point and the fact that we know that these are all horizontal lines, we are asked to find the equation of these horizontal lines. And to do so, like Mr. A said, we just have to look at the y value of each of those points because the y value is going to be the same for every single point on that horizontal line. So we will say y is equal to 4. It doesn't state that we need to have this in general form, so this will be sufficient. The next one, again, we have our point -8, 12. Our y value of that point, and every point along that horizontal line is going to be 12, so we will have y is equal to 12. Quick, try these next two on your own. Okay, so we have y is equal to -3 here, because again, every single y value on that horizontal line will be -3, and y is equal to -1, because every single point along that horizontal line will have a y value of -1.
See if you can determine an equation of each of these lines here. I look at these, I notice that they're horizontal, because they're just going lefty-righty, lefty-righty.
Whoa, that's your axis, Mr. A.
Psych! Lefty-righty. Good catch. If only somebody had pointed that out earlier. Oh, wait. It was you. This height above the axis is always 6. 6 above, it's 6 above. So my y value is always 6. It doesn't matter what x is. My y value will always be 6. Similarly here, it doesn't matter what the x value is. I'm always 5 units below the axis. 5 units below. It's constant the whole way through. Y is always at -5.
So taking a look, we've talked about horizontal lines. We're going to talk about vertical lines as well. Kind of like this one here. The slope of any vertical line is undefined, and we can see that in this point, or in this vertical line that we have highlighted. This point in green here would have the units, or the coordinates 5, -1, and we can calculate its slope, right? It's rise over run. Our rise is 1, 2, 3, 4, and our run is 0. And any number divided by 0 is undefined. So our slope is undefined. Okay. Taking a look at any point on that line, like the one that we have in green, the one that's in black, maybe even this one. This is 5, -5. What's similar about all those? Well, the x value is constant throughout it all, right? The x value here is 5, 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 and here is 5, and here is 5. So at any point along that vertical line, our x value is going to remain constant. And as such, looking at that point, we can say our equation of the line is going to say, or be x is equal to 5, because the y really doesn't affect what our line is going to look like. In general form, we can go ahead and move that 5 over to the other side to ensure our leading coefficient, that a coefficient of x, which is just 1, is positive. But all we really have to look at is the x coordinate of that specific point on our vertical line.
So if we're given a point, we can determine an equation of the vertical line that goes through it. I dare you to try it. Hopefully you have at this point. So if it's vertical, that means x is always the same, and it doesn't matter what y is, right? Because no matter what y value we're at, x is always the same. Therefore, I'm just going to say x is equal to this x value over here, which is 4. And in the same way, I can do the others. Now note, this isn't in any particular form of a line that we've used, but again, it does not say what type of equation, just any equation really. Over here, x is some value. X is specifically that value. So no matter what the y value is, x will be that far. It'll be 5 units left of the vertical axis. And then last, x is equal to 1, because that's the x value right there.
All right, we're going to take a look at these last 2 examples, and we're going to look at the vertical lines and the equations of them. Again, be sure not to confuse them with the axis. Right? The axis is going to be labeled as well as have a scale marker to indicate what the lines are going up by, so please be sure not to do that. Notice here, our vertical line is 2 to the right of our y-axis. So at any point along here, we are 2 away, 2 away, 2 away, 2 away. So our vertical line will have the equation x is equal to +2 because it's 2 to the right. And for this last one, we are 1, 2, 3, 4, 5, 6, 7 to the left. And we're 7 to the left there, but also here, and also here, and also here. And if we are 7 to the left, then we are 7 to the negative side of my y-axis. Anyways, that is it. That is all. Try these textbook questions. We are looking at a quiz right away, and that is the last section of our unit. So we can also expect a topic test coming up soon. With that, we bid you farewell. Farewell. Whew.
Yes, we do hope that you fare well. The end.